Hi, welcome to the third video of Electrogravity where we will be discussing Pretonics. Electrogravity is the third paper of ethereal mechanics, and Pretonics is the third video of Electrogravity. Electrogravity is video series number 3. So the topics we're going to discuss today, we're going to cover a user question based on the previous video. Then we're going to jump into a little refresher of natural units. Then we're going to discuss pretons, pretonic radiation. Then we're going to derive the magnetic force, inertial force, and then we're going to have a discussion about pretonic charge. Tibor has been with me a long time, probably 20 years if not more. Not as a Patreon, but as a follower of my work. And I thank him very much for that. And so his question is, if ether is like a fluid or gas consisting of particles, then it makes no sense to me. How can a preton consume ether particles? What happens to those consumed ether particles? My belief so far is that pretons are analogous to neutrinos, consume only the kinetic energy of the ether, and so ether particles bounce back at a lower speed. Thus, a preton converts the thermal energy of ether into electric and magnetic energy. And then gravity would be an ether temperature gradient around matter. Okay, there's two parts to this. We're going to answer two parts. The first part, the easy part, is, well, if you're going to explain gravity as an ether temperature gradient or a temperature gradient or something of that nature, you need to come up with a way to explain inertia with that same mechanism. Okay, I'll leave that at that. As far as the ether being a kind of fuel and using a particle model, don't worry about that right now. We kind of discussed this in one of the earlier videos way back, but I'm going to discuss it again because we kind of touched on it in the first video where we discussed the overall big picture. Now what I did here is I revised the big picture because in reality pretonics and ethonics are kind of at the same level, and we have missing pieces of pretonics and ethonics. And the way I should have represented this is we have an abstraction layer that fills in the parts we need to fill in with abstractions so that we can explain everything going up the rabbit hole. Okay, and where we started 20 years ago, the abstraction layer was right here where electromagnetism was, and we've moved the abstraction layer back as we've filled in the missing holes. You know, so those people that don't know what an abstraction is a false model that gives you right answers. Let's say it that way. Like, for example, the model of gravity. Sorry, this is clipped a little bit. So basically, this model here was developed from empirical data where we measured the masses and the forces between them, and we came up with a mathematical abstraction that related the forces felt between the two masses. This doesn't explain how gravity gets from mass A to mass B. It doesn't explain any of the mechanisms underlying. All this says is we have measured this effect, and this mathematical abstraction mimics the effects we observe accurately enough, and this measures the effect very accurately, in fact. Okay, but because we have this abstraction, it's useful. We can use it for now, but eventually we're going to have to explain what is it that goes from mass A to mass B to cause gravity. Another abstraction we use is like when we use the contour lines on a topographical map. This allows us to use a two-dimensional map to give us three-dimensional information. Okay, this is an abstraction. You can't go out in your backyard and dig up the 200 meter above sea level line with a backhoe. You're not going to do that. This is just an abstraction. The heart. This is an abstraction, a symbol. A symbol is an abstraction that we use to represent either one of two things, the physical heart that beats in your body or the concept known as love and all that other stuff. Okay, this shape in no way represents the accurate shape of the heart or accurate shape of love, but this is the symbol we use to represent that. And the symbol is useful. We can communicate this idea to each other that we know about, but this shape does that purpose of the communication. And the fuel paradigm that we talked about, the ether being the fuel. Yeah, I don't know how the ether stores the fuel. The ether may or may not be particles. We don't know, but we can use particle models very accurately. And the example I was going to show, but I can't find it right now, is that in the transvariance, we did simulation with light being particles. Light is not particles, okay? But the model, the simulation, the computer simulation, treating wavefronts as a series of particles works very well. Okay, and we can use all of these abstractions as long as they give us right answers, but all of these abstractions have limits, and one day we're going to run into the limits of the fuel paradigm abstraction, and then we will have to replace it with something better. But right now we're going to use it while we can use it and take that abstraction as far as we can go before it does not give us the right answers, and that's the point where we're required to replace it with something better. And we're going to show you how this refinement process is going to work. Okay, so right now we're going to treat the Preton as a sphere at our present abstraction layer. And then we're going to show you in the next video, we're going to derive the constant g from this abstraction layer. So we're going to go up and derive a part of electrogravity using the present abstraction layer. And what's interesting about this is that we have g, which is a constant, 2 pi, which is a constant, the speed of light, which is a constant, mu naught, which is a constant. That leaves these guys, the ratio of a Preton to the charge of a Preton has to be a constant too, which is very, very illuminating. It's very exciting. There's a lot of interesting ideas that have come from the concept that the charge is intimately related to the radius of a Preton. It means the charge is probably based on the shape of the Preton. Okay, and any shape that where the quantity of something is relative to the radius, that sounds more like a ring to me. And so here we have used the abstraction, gone up the rabbit hole to derive a piece of information where we gather other information that gives us a different story and fills in a little piece of a missing puzzle underneath the abstraction layer we're currently at. Okay, let me give you another example. In the original attempt at electrogravity, this is about 5 or 6 years ago, and I'll give the link to this video. Okay, we came up to the idea that ether cannot be a unary fluid. What's a unary fluid? In other words, our present abstraction layer, we are treating ether as a unary fluid, a simple unified fluid. Whether it's particles or not, it doesn't really matter. We can use this unary fluid model. But then when you start considering light, okay, which we did back here, okay, the problem with light is in order for waves to propagate in a transverse mode, it requires two mediums, because water waves, they propagate at the boundary between water and air. String waves, vibrating string vibrates. It needs another medium. You can't just have a solid mass of string. You need space for that string to move left and right. So that's at a boundary between string and air. And all transverse waves require a boundary between two mediums to propagate. And therefore, ether must be a binary medium. And right now, the model we're using, which is part of our abstraction layer, okay, is that Pretons or ethons are both positive and negative. But we don't know how they interact. We don't know how the energy is stored, if it's stored between them or they're each individual. We don't know this yet. Oh, and this little thing here, I'm using the picture of where we are now, this picture back here, but what I'm saying with this is, instead of me having to go dig up what the earlier thing would have looked like, I'm just putting this thing earlier versions here. So what we're talking about here is the earlier versions of ethereal mechanics. Okay, and that's, again, going back to this video, here's the link to the video number 35. We came up with the concept that negative Pretons, this is my original symbol for a negative Preton. We're not going to use this going forward. We're going to come up with something else. As it moves through the the ethons, so empty space is filled with positive and negative ethons. That's our binary fluid. As the negative Pretons consume the ether particles, these ether particles come in very tightly knit pairs. Maybe that's how the energy is stored. Don't know yet. Okay. And so in other words, the Preton possibly consumes, the negative Preton possibly consumes the positive ethon, and the negative ethon flies away. And on the positive Preton consumes the negative ethon, and the positive ethon flies away. That's the original model. I am not sure this is going to be the model going forward. Right now, we don't have enough information to say it's this, or maybe it's more like Tibor is saying, that it's actually the energy between these two particles that is consumed. Okay, either way, the fuel paradigm we're going to use, it somehow the ether conveys the fuel to the Pretons. That we're extremely sure of, We'll get into the actual mechanism when we start filling in more pieces and we can start connecting, tab A into slot B kind of stuff. But right now we're going to use the fuel abstraction until we can find how the underlying fuel is actually carried from ethons to pretons. Okay, the other gateway model is that, again, in the earlier things, I was trying to take the abstractions and derive, electromagnetism, trying to take electromagnetism to the new version, and I couldn't get hit. I couldn't get a hit. I couldn't make it work. And that's when I realized that we have a problem with mathematics. And so now I had to reinvent math and give us a proper divide and a proper multiply operator for vector math. That's what Vortrix Algebra is. And that ended up causing changes all up and down the rabbit hole. Okay, so how the refinement process works, as we start correcting things and filling in and making patches and corrections and filling in holes in the we're going to move the abstraction layer back to the point and just keep moving it down the rabbit hole. But again, every time we move the abstraction layer back, we got to still go up the rabbit hole to see if there's any changes that could give us more information about the holes underneath the abstraction layer where it is right now. Okay, and we're going to keep repeating this process until all the holes are filled in. That is the refinement process. And I think I've actually explained this better here than I explained it in the electrogravity paper. And again, the little symbol we use for it is we're going up and down the rabbit hole, filling in the holes as we go, just like painting a wall. It's not going to happen in the first stroke, okay? But as we keep going up and down, we're finally going to fill everything in. So let's talk about natural units. Humans have been using a system of units which cloak nature's fundamental structures. When uncloaked, Mother Nature will show you everything. Watch how simple this is. So back 20 years ago, this is where the abstraction layer was. What I've done was I took experimental data of inductors and used a computer search algorithm to find the empirical model that would fit the experimental data. And that's what this is. This is an empirical curve fit of the experimental data. And the regression formula, the regression algorithm came up with a coefficient of relation, which is identical to what they use for magnetism, Km, which is mu naught over 4 pi. And the units of this are kilogram meter per coulomb squared. Now, what was interesting, if you look at this very closely, it looks just like F equals ma. You say, well, what about the minus sign? Well, that's okay, because when you push on a heavy object, the inertial force that's going to react to you is opposite to the direction of acceleration. So this represents the inertial force acting against your applied force. So the minus sign is very valid here. And in fact, if we pull m out and look at what it looks like, it says, well, mass in kilograms can be defined in terms of a constant and two charges separated by a distance. Well, that's pretty amazing. This blue gunk thing shouldn't have been in here right now. We'll explain that in a second. And so if you just take two unit charges separated by the classical electron radius and using 1 times 10 to the minus 7 as km, you'll come out with the mass of an electron with more digits of precision than they presently have the mass of the electron measured. That is stunning. But then I'm like, well, why can't we just define mass in terms of this? Why do we need this other gunk over here? And if we actually look at this equation with a little bit more detail, this constant, if you just put the units of this constant out here, kilogram meters per coulomb squared, you notice these two just cancel each other. So really all Km is simply a means to convert natural inertia into false inertia, the kilogram. This blue gunk has been hiding the natural mechanism of nature. And there it's interesting because Km had been misidentified as a magnetic constant for centuries. So what we're doing in ethereal mechanics is we're going to introduce a natural unit for inertia to disambiguate it from mass. Mass is more appropriately a quantity of stuff. It is not the inertia of stuff. And many years ago, just like scientists disambiguated weight from the quantity of stuff, we also have to disambiguate inertia from the quantity of stuff. And so we're going to this is going to be the only new unit that we're going to introduce in ethereal mechanics, that I'm aware of right now anyway. And we're going to use B because we're getting rid of the B field. The B field becomes obsolete. So I'm going to repurpose the variable B to represent inertia. And the inertia is Coulomb squared per meter. And the name of this is Burles, which is short for Burley. And Burley is the representation for square coulombs per meter. And so if we look at km now, and we change the units of km out to and replace meters, coulomb squared per meter with Burles, we see here that km is nothing more than a mass to inertia ratio. Okay, and anywhere that you need to convert natural units to legacy units, you just have to multiply by km. And that's in like most of the cases anyway. So now, like for example, if you want to convert Burles to kilograms, you multiply Burles times km and you get back to kilograms, obviously. So now we're going to talk about other units. Let's talk about force. In ethereal mechanics, force is defined as square amperes. Those are the natural units of force. And instead of coming up with a new name for this, I was going to call this squamperes. But it got to the point where I'm introducing so much new stuff, it's going to be too much for those tiny physicists' brains to handle as it is. Trying to confuse them with new unit names is just going to be a nightmare on top of a nightmare. Okay, so I decided I'm going to keep unit of force as the Newton. I'm just going to call it the natural Newton. And we're going to represent natural units with black ink. So if I don't have the word natural in front and it's written in black ink, you're assuming natural units. Okay, so the natural unit of force is the square ampere, which is also Coulomb squared per second squared. To convert natural newtons to legacy newtons, you multiply natural units by km, and it works out to kilogram meters per second squared. Okay, and again, we're going to be representing legacy units in blue ink to keep them straight. So if you see a blue F, that is legacy newtons. If you see a black F, that is natural newtons. Okay, to keep them straight, because sometimes we want to go back to legacy units so we can compare, and we're going to do that in this video as well. Okay, so let's jump into Pretonics. Follow me down the rabbit hole. So what is a Preton? Well, is it a sphere? Is it a ring? Well, I don't really know yet. But we're going to have an abstract model for the Preton that we're going to use. Because it could also be this. I mean, suppose you have two parallel universes. One parallel universe is filled with ether, and the other parallel universe is filled with anti-ether. And the Preton may just be a wormhole between the two universes, allowing them to annihilate each other. And then asking where the components go is not relevant because they disappear. They annihilate. Okay, so I could probably make this model work too, this abstraction work as well. Okay, but right now we have a decent abstraction that we're going to use for now. We're still going to use a sphere, even though it's probably not a sphere, because that'll work for now. And it's an inertialess charged particle. Well, what's charged? We're going to discuss that in a moment. And then there are positive and negative pretons. And the properties of the pretons that we're going to consider are the position, velocity, and acceleration relative to the medium, its charge, its volume, and surface area, and a radius, of course. We're going to still use the spherical model until the spherical model no longer gives us good answers, or unless we can find something better. Okay, now the Pretonic field is the radiation emitted by a Preton in motion. And let me show you my little friend here. Where did you go? Okay, so as Pretons move through the medium, they disturb the medium. The disturbance travels away from the point of disturbance at the speed of light. The Preton cannot move faster than the speed of light, otherwise it'll crash into its own Pretonic field, which would prevent it from going further. Okay, and now this only shows how the disturbance propagates away. I'm going to add the arrows, and these little arrows show you the force on the disturbance. Now this is kind of a misnomer because a Pretonic field is a matrix field. It doesn't have vectors yet. There's a lot of information in this field. This would be the old way that I would have shown the vector ampere field, which is the original version that I had before I realized it had to be something more complicated. We need to fix mathematics. So now instead of being a vector ampere field, it's a ampere matrix field. So this little arrows being shown here are a little bit of a misnomer. They're not the most complete representation of the Pretonic field. And you'll notice the arrows get smaller and smaller in size as they go away. That shows how the amplitude of the effect diminishes with distance from the Preton. Okay, and the units of this are amperes, which is equivalent to square newtons. Those are natural newtons. Okay, and the R is defined as the distance between some point that you're the test point, the position of the test point, or if you got a Preton, it would be the position of the target Preton, to the position of the source. Okay, and we will also call this Pretonic field. We call it Pretonic radiation, and we also call it the ampere matrix field. And because it flies away forever and ever and ever and never comes back, it's not really a field. It's more of a form of radiation. But we're going to call it a field anyway because we have so much stuff written that says field, but whatever. Okay, the Pretonic field is how the source Preton disturbs the medium. The Pretonic force is how a target charge couples to the disturbance. Okay, that is our force field paradigm. So here is our Pretonic field from the source. The way that a target couples to it is by taking the time derivative of the field, and then you multiply that by the charge of the target Preton times the direction vector r. Now, I don't know why I have to multiply, but I have to multiply this to get the right answer. I'm working hard to find out where this comes from. I think it comes from the fact that this field radiates away at the speed of light in a radial force, and I'm pretty sure that I am not accounting for, but it doesn't matter. Right now we get the right answers with this, but I'm trying to find this out because if I can figure out where that R comes from, I might learn more or learn about other fields, other things that we can measure. So right now we're going to derive this. We're going to do this derivation right here. So let me head off to that derivation segment. In this talking hands demonstration, we're going to do the derivative of the matrix ampere field. The green text represents the part we have to do the derivative on, and the black text is what we're going to multiply after we're done doing the derivative. Now, one of the things we need to establish is that the vector r is defined as the position of the target minus the position of the source. And the derivative of r, which we will use, is the velocity of the target minus the velocity of the source. So just get those out of the way. We're going to need those later. Now, sometimes I have to put this pen over here to keep the camera so it will have something to focus on. Otherwise, it'll just blur out on me. Now, some people say, well, why don't you just use the chain rule of standard calculus? Well, if we did the chain rule of standard calculus, we would get something that looks like this. We would get and I'm going to do this in red, we get the derivative of the first times the second. So we can look at the first as v and the second as 1 over r. So the derivative of the first would be the acceleration times 1 over r plus the first times the derivative of the second. Now the derivative of 1 over r is minus 1, so we can get rid of that, put a minus sign there. 1 over r squared times the derivative of r, which would be the velocity of the target minus the velocity of the source. Okay, and so this is very close. Let me just write this the way it might look if we kept it in vector Vortrix algebra. And so we'll keep that as a reference. So I'm going to show you the reason why we can't just do this chain rule with Vortrix algebra is because in Vortrix algebra it's a higher dimensional mathematics. And in higher dimensional mathematics, is a lot less ambiguous than regular arithmetic, because in a regular arithmetic we get a different answer here because of the rules of regular arithmetic. Now when we do the full-off derivation in Vortrix Algebra, you can see we're going to get very close to this, but not exactly this. So let's do that now. Again, I'm leaving that pen there so this thing will focus. So what we have to do here, because there is no table of Vortrix derivatives already ready to go, we're going to have to do this derivative the long way. And that is by taking the limit as delta t goes to 0 of the first velocity plus the acceleration delta t divided by r plus r dot delta t. Make sure we keep that together because that represents a matrix, minus the original the whole thing ambiguously divided by delta t. Ambiguously divided means that this is a scalar divide, and scalar divide is neither right nor left. And so we can use the ambiguous divide in Vortrix Algebra when we're dividing by scalars. Because in Vortrix Algebra, okay, you can divide by the right and you can divide by the left. And right division and left division are different. And likewise, right multiplication and left multiplication are different. Okay, r times v is not the same as v times r. The magnitude is, but not the ultimate direction. Okay, so let's continue down here with green ink. First thing, since I've done this a million times, the thing I know that works out the quickest and the simplest is to multiply the top and the bottom by this denominator here. And this is a right divide, and so the way we get rid of a right divide is with a right multiply. So we're going to right multiply the top and the bottom by this term here. That's going to leave us, I'm going to push the limit off to the side so I don't have to keep writing that down. That's going to leave us with v plus acceleration delta t minus v over r times r minus v over r times r dot delta t, and the whole thing divided by delta t. Okay, because this is a right divide and a right multiply, they cancel. That leaves just v here, so we get v minus v. So these guys cancel. Now every term left here has a delta t. Oops, I'm sorry, I forgot to multiply the denominator by r plus r dot delta t. Okay, sorry about that. So now that every term remaining now has a delta t, so we can cancel a delta t from everybody. And so what do we have left over? We have acceleration minus velocity over r times r dot, I'm going to put this guy in now, vt minus vs, times, oh, not yet, divided by r plus r dot delta t. Okay, now we're going to take the limit as delta t goes to 0 and over this thing, and what it happens is this delta term goes away. Okay, so now what we have left here is we have a vector r in the denominator. And because this vector r got there, because it was right multiplied by the denominator, right multiplying by an ambiguous denominator is the same thing as right dividing the terms by r. So we're going to reduce this. Now that we've done our limit, we're going to reduce this by dividing both terms by r. I'm going to move this up to make more room. And so we have a right divided by r. Oh, I switched ink, so what? That's a matrix minus V over R times Vt minus Vs. This whole thing is right divided by R. This division has to be done last. Order of multiply and divide matters in Vortrix algebra. So I just can't roll this in here and call that an R squared. And that is fundamentally the difference from what we did here. You can see the result we had here. We have the A over R and we have the V over R squared, but the R's are split. You have one R here, one on the other side here. This and this are fundamentally different. And that's why we can't just use a derivative table with Vortrix algebra. We have to do everything out. Eventually, we're going to have to produce a table of derivatives and integrals for Vortrix algebra. That's another thing of time I don't have, but eventually we're going to have to get to it. Okay, now what we're going to do is we're going to multiply these other terms, these other components we're going to multiply through by the Q's and the R up here. Okay, so this works out to be minus Q SQT times A over R. And we multiply this by R. That, and we'll do the same thing to the other term. Now, because we have a minus sign here and a minus sign here, they cancel, and we're left with a plus QSQT V over R VT minus VS, excuse me, over R, and this whole thing is multiplied by R, excuse me. All right, so now we can divide through. Now, one thing about Vortrix vectors, and all vectors actually, a vector is basically can be separated into two components, a magnitude and a direction. The symbol means that's the direction component of the vector, and that's the magnitude component of the vector. The magnitude component of the vector is a scalar which can slide around. It uses the simple rules of arithmetic. The direction part has to comply with the vector rules because it's actually a vector. So this scalar we can slide around. Okay, so basically when we have R over here times this, that's the same thing as R divided by magnitude R times R direction. These direction vectors cancel. So this guy can be written as minus QS QT times A over direction R, because direction R, oh, I'm sorry, magnitude R, because the magnitude is all that remains there. Okay, and same thing over here. We got the same situation. We have plus QS QT V over R VT minus VS, and we can divide that by magnitude R. Now, because these are magnitude R's, we don't have to use right or left divide. We can use the ambiguous divide. QS QT times acceleration divided by magnitude R plus QS QT V over R VT minus VS, and take this whole thing and divide by magnitude R. Okay, now the way I like to represent this is I like to break up this R here into its magnitude and direction, because we can move this part anywhere we want because it's pretty much, it follows the rules of regular arithmetic. We come up with the final form, the preferred form of the Vortrix derivative, and QS QT, and then we do V over R direction, VT minus VS, and this whole thing divided by magnitude R squared. So now that is the preferred form. Now, there is another alternative which you will see of this. Okay, this is new induction. This is the magnitude. So this is our inertial component. This is our magnetic force component. There's another way to show this by dividing through and showing these terms separately. You'll see this in the video. So you have QS QT times V over R, and that's V source, Vt minus V source over R. Those V's we've been carrying are all V sources. I just left the S off. Vs. And all of this over R squared. Okay, so you're going to see this in the video. You might see the magnetic force form in this way, or you might see it in this way with the two terms separated. And you can even, sometimes we even show the two terms completely separated, which would look like oops, I forgot a direction there. Well, I extended that too far. It doesn't matter. It just means the same thing. Okay, so the magnetic term could be, these are all three are the same thing. It's just more compact to show it like this, so I'll usually more often than not show it like this. But all three of these are the same. There's no other variations of the inertial form. It's in the simplest form you can show. And sometimes we show it like this or like this to show the separate terms, and we compare it to old electromagnetism and all that stuff, so you can see the comparison between them. Okay, but this is the preferred form, and that is these are the magnetic or the Pretonic forms of new electromagnetism version 5. We're going to show you the other forms as we progress through the electrogravity paper. Thank you. So returning from that video, this is what we got, and then we multiplied by the R and then the charges and the negative sign. And then I showed you how we propagated the R's through, and this is what we're left with. So now we're going to split this into two sections. We have one section here, which is our inertial force. And this section here is our magnetic force. And so what we did is we took our components and we multiplied by Km to convert them to legacy newtons so that we can compare. So let's see what changed. Okay, these models here, 1, 2, 3, 4, 5, represent new electromagnetism version 3, represented with normal vector algebra. Okay, now if we notice, this term looks pretty close to this term, and this term, including the sign, looks very close to this term. And so this is important because these dot products and this legacy stuff here does not have the fidelity to accurately reflect what's really going on. This does. And now the other problems here, this isn't accounted for. And what's interesting is what I've said in the past is that because of this R over here, this looks a little bit more like this guy over here. It looks like this term belongs with electric charge. Now we're going to derive this in one of the last video. We're going to derive this. So don't worry, we're going to show you what our answer for the Coulomb field is in the last video of the electrogravity series. Okay, and you're going to see something like this appear up here when we get there. And now finally, new induction, as I measured it, looks just like the new induction derived from the fundamental field. And this reminds me of a saying by T.S. Eliot: we shall not cease from our exploration. At the end of all of our exploring, we will arrive where we started and know the place for the first time. I like this. It says, we shall not cease from exploring, but when we do end exploring, so we're getting to the end even though we shall not cease. So it's kind of a contradiction, but it's fun. And so that's interesting because in the beginning, 20 years ago, this was the abstraction layer. This was derived from experimental data, and I had no understanding of what this stuff that transferred from the source charge to the target charge. Okay. Now, the problem I had ran into was I had to overcome the brain damage from a college education, which obscured a lot of the ways I looked at science. And then I had to get rid of all this blue gunk to see what was going on underneath. Another artifact left over from bad legacy science. And finally, I had to fix all the broken mathematics out there. And then from that, I was able to push the abstraction layer down the rabbit hole until I could derive new induction from the lower level abstraction. Now, again, we're going to keep going down the rabbit hole to find out what everything is, but at least now I could get this guy from a lower level abstraction. And the beautiful thing is that from when I found this little guy, he carried along his 800-pound gorilla friend with him. And that was this is a great coup in physics. And I could not have done this without the corrections in mathematics to get there and the removal of the blue gunk that we no longer need in physics. Okay, and again, we're going to discuss a force field paradigm. As a source preton moves through the medium, it causes a disturbance. Okay, and the force is the manner in which a target preton couples to the disturbance. And what we've learned between my little friend and his 800-pound friend, gorilla friend, is that there could be more than one way that a preton can couple to a field. Okay, we got to keep that in mind. Not think only in one term. There could be two terms. So where are we with respect to where we want to be at the end of electrogravity? Well, we have this force field paradigm, and we have the field of magnetism and the inertial force. This is the field, and these are the two methods by which this field is coupled by target pretons. Okay, the next step, in the next video, we're going to dive into what's a gravitational field and how do pretons couple to the gravitational force. And then we're going to discuss what the electric field is and how the electric force is coupled to pretons. Okay, now in the New Electromagnetism version 5 paper and video series, we're going to demonstrate how to apply these new models to actual experiments. You can try and do this on your own, but there's things we need more than just the better fundamental models of the magnetic force and the inertial force. We need a more advanced model of conductors and more advanced model of magnets. So what is pretonic charge? Well, pretons disturb the medium just like a plow truck disturbs the snow. And so charge is an abstraction that quantifies the magnitude of the disturbance. Now going back to this guy over here, we learned that there's a high correlation to the radius of a preton and the charge of a preton. So that means the charge and the shape are somehow tightly related. Now we can look at this with a plow truck. Here's a plow truck with a small plow. Here's a plow truck with a much bigger plow. And what we could do is we could abstract charge is kind of like the size of the plow on the preton. Okay, and that if preton has more charge associated with it, that means it has a bigger plow. And it could, but this is saying to me that pretons and their plow size are tightly related, and therefore it's based on the shape and size of the preton itself. And that's great because that means we might be able to eliminate charge altogether and be able to soon, one day in the future, say, because of this shape of the preton, it couples to ethons this way, and get rid of the concept, the abstraction called charge altogether. That day is in our horizon. Okay, now right now, we're still going to use the charge abstraction. And that's okay because we use other abstractions in life. We have wire size gauges. Now, whoever came up with the concept that a larger wire gauge conducts less current, I'd like to choke the guy that came up with the wire gauge. That is so confusing. You'd think a bigger wire gauge should have more current. It's just the opposite. Shoe sizes are all over the place. IQ score is completely arbitrary. Hurricane force, we got category 1, category 2, category. Tornado force, you got the Fujita scale. The earthquake force, you got the Richter scale. You have decibels, and decibels work differently for sound than for radiation. You have the joule, which is a completely arbitrary gauge, and then you have the fuel gauge. And fuel gauges are one of my favorite because if you have a truck made by Ford or a truck made by GM, the fuel gauges go in opposite directions. So when I bought my new Ford truck, I'd only ever driven GM trucks before, and I thought the fuel was full, when actually it was empty because I'm looking at where the gauge is, not the letter. Luckily, that little yellow light came on to maybe look at it more closely and say, oh my God, it's next to the E. The E is on the wrong side. Okay, so how are you going to quantify this abstraction for pretonic charge? Okay, until the exact shape and manner in which the preton disturbs the medium known, we will still use the charge abstraction. It would be advantageous to base pretonic charge on an existing abstraction to minimize the trauma associated with change. Again, I'm trying to make the transition from legacy physics to ethereal mechanics as easy as possible, trying to keep the amount of change that a tiny physicist's brain has to go through. Okay, so let's see what we can deduce here. Well, okay, an electron has Coulomb charge, also known as electric charge, and supposedly a stationary Coulomb charge emits an electric field, also known as a Coulomb field. Okay, Coulomb and electric are kind of interchangeable here. The words are the same, mean the same thing. It's two words that mean the same thing for classical physics. Okay, but the problem with the Coulomb charge and the Coulomb field is that the stationary Preton emits nothing. So there is no nexus here, no way we can correlate these two together. Okay, the nexus works out to be magnetism because electrons in motion create a magnetic field. And pretons in motion create a pretonic field, which is the basis of the magnetic force. And because electrons are comprised of pretons, okay, we can correlate these two. And don't mind these little lines here. I just cut and pasted the picture. These aren't the shape of a pretonic field. This is just a schematic diagram. Okay, but luckily, two lucky things happened for us. Is when they defined the Coulomb in terms of magnetism. Ironically enough, I always thought they defined the Coulomb in terms of the Coulomb field, but they did not do that. And the other lucky stroke is the Coulomb was defined before the discovery of the electron. Okay, so the Coulomb is an arbitrary quantity. It's not related to the number of electrons. Okay, it wasn't developed in terms of the number of electrons. It's a completely arbitrary quantity. It's the quantity of charge, not the quantity of electrons. So we can use that to our advantage. And so we're going to define the Pretonic Coulomb, because the Coulomb is defined, so the regular Coulomb is defined as quantity of charge, not quantity of electrons. We can repurpose the Coulomb for Pretonic charge. Since an electron has 1.602 times 10 to the minus coulombs of negative charge, and they call this unit the unit charge because nothing smaller has ever been measured. Now, all of our instruments that we have, okay, measure things in terms of electric charge, so that they should not be able to measure something with normal equipment. Anything that's a fraction of an electron is not that big a stretch. Okay, but they do in particle accelerators, when they smash things together, they do get third charges for quarks and things like that. So we can talk in terms of fractional charges. Okay, and the present abstractions in ethereal mechanics posit that an electron is composed of two negative pretons. Therefore, a negative preton has half the charge of an electron. So here's a summary of what we talked about in this video. We talked about the refinement process, what concept of abstractions. Don't worry if the abstraction doesn't make sense with what you think it should be. As long as it gives us the right answers, we'll keep using it until it doesn't give us the right answers. And when it doesn't give us the right answers, hopefully we'll learn a clue that will tell us how to improve the abstraction and keep moving that abstraction layer down and down and down until we can hit the bottom of the rabbit hole. Okay, we talked about natural units, and we talked about that the magnetic field constant is really the mass to inertia ratio, and mass is really a false representation of inertia. Mass is more appropriately the quantity of stuff. It should never have been used as the inertia of stuff. But now we have an electromagnetic representation of the inertia of stuff that we're going to use going forward, and it's now called the burl. We talked about Pretonics. We gave an abstraction for the Preton, the Pretonic charge. We talked about Pretonic radiation, which we also call a field. And we talked about the magnetic force, which we will sometimes still call the magnetic field. And we talked about the inertial force, which we will still also call the magnetic field. I'm sorry, but this field thing has gotten... it's too ambiguous, so it's going to be used poorly all throughout this until I can learn not to use it poorly. I think we just should get rid of the concept of the field. But unfortunately, it's in too much of my literature right now, so take it out with a grain of salt, or a grain of thought. I like that. So the next video, the fourth video, which is the third index, we're going to talk about gravity. I kind of changed this up a bit. We're going to go into the model of matter. We're going to talk about inertia, time dilation, the gravitational field, gravitational force, and then the derivation of the constant g. And we're going to save the best for last. Because electric field and electric force That is going to be the most difficult of all of these derivations, so we're going to save this one for last. At the very end, we're going to show you the complete field models for new electromagnetism V5. And this will be the last video of electrogravity. And then the next point is we go off and we're going to develop all the videos for new electromagnetism V5. And hopefully we'll get new electromagnetism V5 paper and videos out before the end of 2022 so that we can devote all of 2023 to cosmology. And hopefully through all of that time, we're filling in some more pieces of the puzzle below the abstraction layer so that we can keep moving that abstraction layer lower and lower into the rabbit hole. So thank you very much. If you can help, I'd appreciate this. I'm doing this. My number one contributor to this work is my day job. Okay, if you can help out, become a Patreon member. This link is supposed to work, but it doesn't seem to work. This one is definitely a way you get there. Okay, if you can give me $5 a month, you'll have access to all of the technology-related videos, and you can see things that I have not released to the general public, and some of it I will not release to the general public. Okay, we have a blog site. So far, we have people collaborating on EM projects. Sorry, I don't have time right now. When I get to the end of electrogravity, I'll probably have some time to spend time on this site. So thank you very much. No more voodoo physics.